Hello everyone, so in this video, let us now talk about the second important concept while going through concurrency in Golang. The next topic that we will learn in this video is the weight group provided by the sync package. Okay, we'll talk about how we can import that, what is the actual main use case of the weight group and why it is so important that it actually gets a full video on it. So let us start with it. So sync group is a synchronization primitive in Go that helps coordinate the execution of multiple Go routines. In the previous video, we have learned about channels. So channels is used to transfer and communicate, you can say, values or information between two Go routines and do some synchronization as well. Now wait group is also used to coordinate between different Go routines. We'll talk about the syntax, don't worry. It allows the main program to wait until all the Go routines have completed their task. That is the main USP of what wait groups can be used for. A sync wait group is a counter that increments for each Go routine and decrement when the Go routine is complete. That is the main crux of what it is used for. There's a counter which keep on incrementing when each Go routine is spawned up, and when each Go routine is like completed work, then only it will decrement the counter. So the main program will wait until the counter will become 0. Because if it doesn't become 0, which means that there are still some Go routines that is doing some work. So why should I close my program? I hope you understand. If the main Go routine spawns up and it completes its work, it will close, and the other Go routine which were still working, they will not get a chance to complete the work because everything will get terminated. But the main Go routine can wait. Why? Because it can get a signal from the wait group that still there are some Go routines that are doing some work. Don't actually stop. You have to wait for some time. When all the Go routines will complete their work, they only stop. That is what the main use case of wait group. Okay, so this is a very important concept. Let's take some examples. Going through some code, it will become more clear to you. Let's take this example. So let us talk about each and every line and how it is actually working one by one. So this is the main function that will spawn the main Go routine. Now this is the main syntax that we'll be using to create a wait group. So WG wait group sync, in the sync package you will call this wait group to create the wait group. Now we have created a variable. So initially, like when we started, the value is initialized to 0, which means that there is no Go routine that is being spawned here. Now what you can see is, now let's say that you want to create 3 Go routines. So let's say each Go routine we call as a worker because it is doing some work. So we are calling that as different workers. So we will tell that we will create 3 Go routines and this is the worker count. Now what we'll do is that because we are going to spawn 3 Go routines, I will add, using this add function on this wait group, to add the number of Go routines I will be spawning. So this is actually used to tell that I have to spawn 3 Go routines. Remember that if you give this wrong number, the program will get not, like it will not terminate, because this will only terminate when the number of Go routines come down to 0. This actually tells that I am going to spawn 3 Go routines, and when the Go routine's work is over, you have to decrement it also. But if you do not decrement it, this will keep on waiting and it will never stop. So it will go in a never-ending loop. So always keeps that this counter, if it increments the number of workers or number of Go routines, it should also decrement that same number. So we have to add, let's say we have added 3 as a number in the wait group. Now the next thing is that we are using a for loop to create 3 workers. So this is a function call, we'll go, that is written here. This is a function call that is taking this wait group as an input and the workers, and it taking some I as an input, and that is spawned as different Go routines, because every function call is spawned as a different Go routine. This for every for loop, I equal to 1, I equal to 2, I equal to 3 till the 3 workers. This will be called 3 times. So 3 times this Go will be called and 3 Go routines will be spawned. 1, 2 and 3. Okay, this will spawn 3, and because we have spawned 3 wait group, like 3 Go routines, I added 3 in the wait group. Now what you can see is that when this main go routine is running, it will create the wait group, it adds 3 in the wait group, it spawn 3 go routines. Then when it goes down, it has to wait. This is the actual thing that will help you to wait the main go routine to terminate. This will check that whether the wait group is 0. The wait group is not 0, so this main go routine that is running will pause at this time. It will stop its execution. It will wait till the wait group becomes 0 because it is added as 3. It has not become 0, so it will wait. So it will wait. Now it has spawned 3 go routines. Now let us see what will happen in the go routines functions. Let us see above. What we are doing in this worker function is it is in the ID and the address to the wait group. What we are doing is that, let's just remove differ. We'll first print that we are starting on the worker, and then we are doing some work. We are like assuming we are doing some work, so we are mapping that particular work with a time dot sleep, that we are doing some work. So we are assuming that we are going to sleep for this amount of time that is passed in as an ID. So let's say 1 second, 2 seconds. So the worker will be working on those tasks, and in the end, when this task is done, we print that the worker has done the task. So defer will be called when this function call is done. So this function call is done. Defer will be called that this task is done. And then you can see the next keyword, that wg wait group dot done. This marks that this wait group, because we are sending the address to it, it marks that this go routine that is spawned here, like because it has spawned 3 go routines. 3 go routines mean that this function is called 3 times. This function, which is a single go routine, will give wg.done, which means that this is done. So whenever this is done, then only this wait group is marked that it is done. So this will be marked 3 times because it is done and called for 3 different go routines. So when this marked is done for 3 times, it will be like -1 -1 1. So this will add 3 to the wait group. The wait group initially was 0. Then this has added it to 3. And for every go routine, it marks as done. So it will subtract 1, subtract 1, subtract 1, and it will turns out to be 0. When all the go routines have done, they have marked their task as done. Then the go routine has done, and so in the end, this wg.wait is released, and in the end, we'll print that all the workers have finished. So let us check out with the code. So package. What you can see is that the first is printed, all these workers have started, then they have done in this manner, and then all of the work. So all of them started the work, then they are doing some work, like simulating some work, then all of them have completed their work in the same, like in one and the other time, and then they have given the signal that it is done. Then the main go routine will overcome this wait and print that all the workers have finished. So that is how wait group helps to synchronize and should not allow the main go routine to terminate before all the go routines have completed their work. So they are synchronized so that they all work with each other, they work and then signal the main go routine that it is done, and then only the other things will. So if you want to somehow synchronize or actually coordinate between different go routines, then wait group is very essential. That is the overall idea. This is a very good example to understand how wait group works. So you can pause out and see the code as well. Okay. Let's move on to the next part. The next part is one more code that using wait group, it ensures that the main program doesn't proceed until all the spawned routines have completed. It prevents race condition and ensure proper synchronization. There is one more important code. Let's talk about that code and then we'll do the next one. Let's check this. So what we have seen here is that, let's just imagine that we have some task. We have some task in task 1 in place. So we have to first perform task 1, then we have to perform task 2, and then when both of these tasks are done, we have to send the complete task, the complete work to main function. So the main function calls task 1, task 2, asks them to complete both of them. Two go routines are spawned. One go routine, first the task 1 should complete. It should signal that and give the signal to task 2 that okay, I'm completed, now let's complete task 2. When both of them are done, then the main go function said that the complete task is done. Let's now print it out and complete it. That's the thing. We have spawned two routines, but they depend upon each other. The first task should be done, then the second task, so they should be synchronized between them, and then the main function should get a signal, so it should wait for both the tasks to be done, should be combined to them, and then the main function to stop. So that synchronization, that waiting part, all should be handled using wait group, and synchronization and transfer of all of this value can be done using channels. So we have learned about channels as well. So in this example, we'll talk about and mix both of the things that we have learned. Let us see here. So what we have done here is that this is the main function. We have created a wait group. We have created a buffered channel here. Okay. Now what we have created here is that we are creating one go routine. So we are spawning one go routine. So we have to add one in the wait group. Whenever you're creating a go routine, it's better practice to just add one to the wait group on the top of it. So we are creating one go routine, adding one to the wait group. Okay. And the best practice also is that in the go routine that you are spawning, just write down on the top defer wg done, which means that whenever the complete part is done in the go routine, it will defer and complete that it is done and mark in the wait group that this go routine completion part is done. So what we are trying to do is that go routine is now doing some work, and when the work is done, it has to signal the other go routine that the task is done. So now it has to send the signal. How it can send a signal? It can send a true boolean to the channel. Okay, so that is why two go routines has to synchronize. That one go routine, when the task is done, the other go routine should do. Wait group is used for the main go routine to wait. It has to wait that the all tasks should be done, then only I should proceed. But channels is used to synchronize. Then I create another go routine. This go routine is actually also doing some work. You have to write down defer because creating a new go routine, adding a one in the top, and this go routine has to do some work, and then it should start the work only when the first go routine has completed the work. So when the first go routine has completed the work, it gives true, and the other go routine is waiting on it. This go routine is waiting on top of it, that when the first go routine has completed the work, I'll fetch from it, and then only I'll start doing my work, and then they both complete the work, so they mark as done, and the main go routine is waiting on top. So these two are spawned as different go routines, and we've added on top of it, so that we added, and in the end, the main go routine is waiting for both of them. So the first go routine will complete the work, signal the second go routine to start the work and then complete the work, and then all the go routines are completed the work. So the main go routine will print out that all the main go routines are complete, like all the go routines are completed the work, and then it will stop. That's the overall logic here. Let's run this out as well. So as you can see, go routine, always the first go routine will first work, and then the second go routine will work. Like how many times I will do it. Okay, and then in the end, the last one. So that is how we can maintain synchronization as well, even though like they run concurrently. Okay, we should know, like if we do not do this, like anyone can complete the work first. If we do not synchronize between them, I think so the second one can complete the work and then the first one. So there is no prediction, like assurance that which one complete the work. But let's say you have some manufacturing part, the first one should complete the work and then the other one should complete the work. So you have to maintain some synchronization between all of them. That is how you can use channel to signal one another. It's also a very good example to understand how wait groups and channels can be used to work to maintain synchronization and concurrency in a program. That's the complete logic and the code part for both of the examples, and I hope you understand the wait group through this example. If you still have any doubts, you can mention in the comment box for this particular video. I will be helpful to understand and clear out all the doubts. Thank you for watching this video till the end. I'll see you in the next one. Keep coding and bye.